All right, 1-2 in Advanced Algebra 2. Today we're solving absolute value equations, which is pretty challenging for a lot of students. You know, you see number 1 here, and they want you to solve for x. And here's what I say. Friends, if they wanted it to be 2x minus 3 equals 17, they would have wrote it that way. But that doesn't say 2x minus 3 equals 17. Doesn't it have these little up and down guys right here, which I hope you remember are called absolute value bars, right? And to refresh your memory, absolute value bars, for long story short, mean make it positive, right? Make it positive. So quick examples. What if I said absolute value of -3? What is absolute value of -3? It's 3 in that case. Absolute value of 2, though. It doesn't mean change the sign. It means make it positive, right? So what's absolute value of 2? It's 2. And even 0, yes, you can't make it positive. 0 is the only number that can't be positive or negative, but absolute value of 0 is 0. Well, those are just expressions up here. Today we're going to solve equations, so I like to start with this basics. What if I told you absolute value of x equals 4? What could I put in for x that would make that a true statement? Give me one example. What could x be to make that true? 4. Would you believe the absolute value of 4 is definitely going to turn out to be 4? Is there anything else that could be in there also besides just a 4? Couldn't x be -4 also in that case? Because the absolute value of -4, won't that come out to be 4 also? So there was actually 2 different situations. X could have been 4, or x could have been -4. And those would make those both work in that case, right? So that's what happens when we solve absolute value equations over here. There is a process. For those who have never had me, I am huge on step-by-step procedures of how to do something. Teaches you how to think. I have that process typed out for you mostly right here. We're going to add a step to it, though, also in here. So first thing first. I kind of call it step 0. Are there even bars with this in the first place? Does this equation have bars? So that's like, okay, now I need to talk myself through this, right? Here's step 1. It says isolate the bars, right? All in math language, isolate the bars. Isolate means get all by itself. Are these bars right here? I don't care what's in them, right? Don't care what's in them. Are the bars all by themselves on one side of the equal sign? Like there's nothing being added to it or times it in front of it or anything like that. Are you cool with that? So isolate the bars. Got it, right? Then check this out. I'm going to keep this red blob here. You just kind of hang with me. What if I called it like x? You know, just like I did right here. Could you tell me what could be in the bars to make this a true statement? Like what could x be in this case? X could be 17, right? That's one possible situation. What's the other thing that x could be? -17. That is exactly our procedure for what we do next. Except it's not x, right? It's whatever the heck is underneath there. It's 2x minus 3. So what we do is we write 2 equations. Let's work together. We take what's in the bars. It's that 2x minus 3. Didn't you tell me that that could be 17, right? 2x minus 3 could be 17. That's one situation. Like, remember, I had that red blob here. It's now going to be a blue blob. Or couldn't that red blob or blue blob totally be -17 in that case? So we set another equation up to the side, 2x minus 3 equals -17. And that's weird for people at first, but what's in these bars right here, if it was 17, we'd be in good shape. So here's what's in the bars. We're saying it could be 17. Or what's in the bars, if it was a -17, we could be in good shape. Does that kind of make sense to you? It's weird at first. All right, now we just do basic algebra to solve for x. Let's do the green guy real here first. How do I get rid of that -3? Add 3, so 2x equals 20, right? And, of course, divide by 2, and x equals 10. Well, here's the thing. This is what's called a possible solution. It may or may not make this true, but we're going to come back to it in a second. So 10 is a possible solution. Let's go ahead and solve the blue guy also. So we're going to add 3 to both sides. What's -17 plus 3? -14. Watch those signs. You're free to use a calculator if you need to, and then totally divide by 2, and we get another possible solution of x equaling -7. So here's the thing. It says solve each equation. Kind of did, but we got to check our solutions. This is where you're going to hate solving absolute value equations, because we have to check these and we got to show some work. So I'm very picky. Please put a squiggle, squiggle, squiggle. Did you see how much space your worksheet has for you to do the work? You know, it's like we need to use all this space provided. We're going to do a squiggle, squiggle, squiggle. By the way, I've noticed just looking around, it's normal. Some people put these two equations on top of each other instead of side by side. Let's work side by side on the next ones. Don't erase if you've done it, but let's go side by side. Trust me, organization is going to make this even better. So let's go side by side instead of this one here and this one down here. Okay? It's just easier for you to read eventually. So we're going to do some squiggle, squiggle, squiggle. And here's what I got to do. I got to substitute our possible solutions back into the OG, the original problem. It's got to go back into the original problem. I'm going to say that again. It's got to go back into the original problem, the OG, to see if this works. And because we're not little kids anymore, we don't have to do every single step, but we're going to sub in. So 10 is going to go in for x. Would you believe there is a bar here? Boom. But here's what I'm saying. I think we could do some mental math, right? If I put 10 in for x, and there's a stinking times 2 right in front of it, what's that going to turn out to be? 20. I don't need to write 10 times 2. I'm just going to put 20. I would like you to put the minus 3, though. The bars are still there, and now that equals 17. And what you have to do, friends, is you have to prove it to me like I'm a kindergartner. A kindergartner is not going to be able to look at this and say, oh, yeah, that's true, that's going to work, right? You got to prove it to me like I'm a kindergartner. So what is 20 minus 3? So it's still in the bars. You can't use the bars until you get one term in there, right? So the bars are just coming along for the ride. People are like, well, doesn't that minus 3 become a positive because it's in the bars? You got to do what's in the grouping symbols first. It's called the order of operations. So you got to do 20 minus 3 first. Then here's where I'll let you say true or false, right? Does absolute value 17 turn out to be 17? Yes or no? Yes. So I go back up to this guy and put a check mark next to him. 10 checked. Like 17 is not our answer. 10 was the answer. 10 was the value of x. Then I put another little squiggle, squiggle, squiggle going up and down. It's almost like a T-chart from geometry. And now we've got to check negative 7. Back into the OG. So put negative 7 in there. And 2 times that is straight up negative 14. Are you cool with where the negative 14 came from? You all good with that? And then I do some cleanup on the inside. What is a negative 14? Take away negative 3. Negative 17. But it's still in the bars, right? And what is the absolute value of negative 17 turn out to be? So is this true or false? Does 17 equal 17? True or false? That's true. So this guy checked. They both checked. Then they say, write your answer in a solution set. We have 2 solutions. 10 is a solution to this guy, and negative 7 is a solution to this guy. So if you still got room down below, you can put them down below. We can also put them off to the side. Here's a solution set. It's that fancy schmancy little bracket like this. 10 is a solution, and so is negative 7. It doesn't matter what order you put them in. If you put negative 7, 10 in there, that's fine. But it's not parentheses, yo. This is not an ordered pair. This is not a point on the graph. These are our solutions, right? 10 and negative 7 in there. If Mrs. Kinderconnect showed you to put x equals on the outside, I don't like it because it's wrong, right? The solutions do not need an x equals on the outside. She does her thing. I do the right thing in this situation. So this is the right thing. There's our, no offense, right? But this is just the way it's supposed to be done. You okay with that? That's weird, right? It's a lot of work. This right here is probably worth about 9 points. You know, like look at all the work that's involved with that. You got to set up your equations, you got to solve them, you got to check them, and then you got to put your solutions in a solution set. So it's a lot of work. If you think you're going to get away with not showing this work, you're going to get a lot of points taken off on quizzes and tests, right? So let's try again. Talking ourselves through the steps. First of all, step 0. Are there even bars in this equation in the first place? Yes. So we're going to go through the steps. Are the bars by themselves? Here they are. Are the bars by themselves? Nope. There is this minus 5 hanging out with it. Let's go over and add 5 to both sides. So the bars are still there. We have not lost the bars. Sorry, my pen freaked out. erase. So the bars are still there. That's a t. Minus 4 equals 5. You cool with adding 5 to the other side? Hey, we're going to add the step 1.5. Here's step 1.5 right here. So after you isolate the bars, step 1.5, I would go here and put common sense. We're going to do what I call the common sense check. In advanced algebra 2, even if you think you're not that great at math, we can all handle common sense. Let's go way back. What the heck do these bars mean again? The bars mean what's in here has to come out positive, right? So look over here. Is the result a positive guy, right? Because sometimes you're going to see this. Like, what if that was a negative 5? I could tell you right now that that is going to have no solutions. Like this guy, if this was a negative 5, this is impossible. And you could go through all the algebra that we just did right here. You can go through this algebra, you go through this algebra, then you go through a check. This one wouldn't check. You go through a check, that one wouldn't check, because it's not freaking possible for an absolute value thing to come out negative. So the common sense check is going to save you probably 30 to 45 minutes of homework time right here using a common sense check. So let me start over with it. It's only our second example. I got the bars by themselves. Common sense. Is this dude over here positive? Yes or no? That means we got to do the work, right? We got to do the work. What we got to do is take what's in the bars, the t minus 4, set them equal to 5. But there's something else that what's in here could be. What else could the t minus 4 equal instead of 5 to make this a true statement? So let me do it again for you. I know it's weird. I'm going to just blob this out. You said that in here could be 5 to make it true. What else could this be? Negative 5. So that's what you're doing. You're taking the blob. This purple blob is t minus 4. Right? T minus 4, you said, could be 5, or t minus 4 could be negative 5 in that case. Now, I need you to notice there are no bars. And those of you who try to cheat and save a step by just putting this t minus 4 equals 5 over here, and this one still has bars, you can't do that. You cannot solve an equation with absolute value bars in it. It is impossible. You have to get rid of the bars by saying this could equal 5 or this could equal negative 5. The two equations we are solving do not have bars with it anymore. It's weird, right? Algebra, woo! It's kind of boring. It's weird. Let's solve for t. That's the fun part. I shouldn't say fun. That's the easy part. What could t equal in blue? T could equal, talk to me please, 9. Or what could t equal over here in green? Negative 1. We cool with those? Those are possible solutions. Very possible. We have to check to see if any of those are extraneous. So, time to check to see if any of these guys are what's called extraneous. They don't make the original problem work. Where to sub in? That's a tough one. Some people try to sub them in here. That's not going to work for you. They're always going to make these true. That's how you got these numbers. Some people try to sub in here. It doesn't work that way. You have to sub back in to the original problem. You have to sub back into the original problem. So, squiggle, squiggle, squiggle. And let's go with 9. And follow me, right? Those who work ahead are probably going to get themselves in trouble. So follow me. I'm going to go back in. And I'm going to do 9 minus 4 in bars. There is a minus 5 equals 0. Here is the toughest thing for even the smartest algebra students to understand. Look at this guy right here. Are there any letters with it anymore? Any X's, anything like that? Any letters? When there's no letters, you are not allowed to move stuff from one side to the other. You're not solving anything. There's nothing to solve for. There's not a letter anymore. We have to simplify both sides, right? So if you want to add 5 to both sides, it's going to get you in trouble because there's no X's to solve for anymore. We have to clean this up. Simplify the left side. You just clean this whole side up, meow, 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 meow. You clean this whole side up and see if they are equal or not equal to each other. So let's do it. We can do two things at one time. What's 9 minus 4? 5. What's absolute value of 5? So I'm going to put a 5 right here. Minus 5 equals 0. Do you see how I just cleaned that up and brought everything else down? And then I do want you to prove it to me like a kindergartner. What's 5 minus 5? It's 0. True or false? 0 equals 0. True. So that means that 9 checks. But don't move stuff from one side to the other. When we start doing more complicated problems, we're still on the easy ones. When we start doing more complicated problems, you're going to get in a mess. So let's try again. We got to check -1. Where are we checking? Into the, starts with an O, original problem. All right, let's put -1 back in here. -1 minus 4 minus 5 equals 0. What is -1 minus 4? -5. But because there's bars, there's a lot of people who don't write the bars down. They're like, oh, I was supposed to put those bars in there? Yes, you're supposed to put those bars in there. They're there for a reason. So isn't this really still 5 minus 5 equals 0, which is a true statement. So far, we haven't had any what's called extraneous answers. So put our solutions in a solution set. 9 is a solution, and -1 is a solution. I know it's difficult to make those crazy brackets right there. Try your best to make the brackets. I'm not going to like grade you. It's like your bracket isn't good enough, you know. It's just not a parenthesis. Cool. It's not a parenthesis. Rock and roll? Yay! Let's keep rolling. Hey, are there bars in this problem? Yes or no? Yes. Are the bars by themselves? Yes. There's not like, say, a +1 with hanging out with the bars, right? There's not like a ×2 or anything. The bars are by themselves. And you want to know something? I'm a weirdo. I don't like the bars being on the right side of the equal sign. I'd rather them be on the left side of the equal sign. So I personally am going to pull the old switch. For those who are remembering their geometry class, this is called the symmetric property. But you see how I took what was on the left side, put it over here, took what was on the right side, put it over here. You also see we have something completely different now. Back here, when we got the bars by themselves, it was just equal to a number, straight up. Plain Jane, a number. Now that I got the bars all by themselves, isn't there a variable with it on the outside? So you cannot do the common sense check. Common sense check only works when it's equal to a number. If there are variables, you have to go through and do all the work, right? If there was a shortcut, I would show you, but there is not. So the idea stays the same. Take what's in the bars, m plus 3, and set it equal to what you see is what you get. Come on, pen, work for me, baby. So 12 minus 2m. You all cool with that? I took what's in the bars. No more bars at this point. No more bars. That equals 12 minus 2m. I got to set up a second equation. You take what's in the bars. I'll answer the question now. What's in the bars never changes. What's in the bars never changes. This was an m plus 3. This is an m plus 3. But this stuff, this is not in the bars. Change all the signs. If this is a 12, he's going to be a minus 12. If that's a minus 2m, he's going to be a plus 2m. Remember, if you can't read what I write, please ask, what does that say right there? You know, but this pen just likes to lag too much, and then it drags. So took what's in the bars. What you see is what you get. Took what's in the bars, changed everybody's signs. Please pause the video and solve both of those for m. All right, by solving the left side, I got m equals 3, and by solving the right side, I got m equals 15. Remember, these are possible solutions. Some of them could be extraneous, so I'll squiggle, 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 and I want to check these guys. Hey, where should I check? Into A, B, C, or D? Where should I check? Back into D. You actually get away with C also because you didn't actually change anything when we switched sides. You know, it is the same thing. So both of these are considered the original problem. You never moved something from one side to the other or divided or anything like that. You just switched. So I personally, let's just go into C, where the bars are on the left and the crap is on the right. Okay? So let's put 3 in there. Absolute value of 3 plus 3, I'm cool if you just go straight to 6, you know. But keep the bars around it, just so the more steps you skip, the more mistakes you're probably going to make, right? So 12 minus 2 times 3, I'm going to write 12 minus 6. Are you down with that? And then I'm going to clean both sides up. The other thing I didn't explain is you should probably start making your absolute value bars taller than your numbers. Like if I made my bars the same height as my numbers, doesn't that look like 161, you know? So make your bars taller, you know, so it's like, okay, that's the absolute value of 6, right? So not 161. So 6 equals 6. Are you cool with that? Check. Let's try 15. So I'm going back into this guy. Absolute value of 12 plus 15, 15 plus 3 is 18, right? And then we'll do 12 minus 2 times 15 is 30. Are you guys okay with where I got these numbers from so far? Sometimes I move fast. Slow me down if you need me to. And absolute value of 18 is how much? 18. Don't force it. Don't force it. What is 12 minus 30? It ain't 18. Don't force it. What is it? It's negative 18. People are like, I thought it was supposed to be 18. It's not. We're checking to see if this works. Does 18 equal negative 18? We all know that's a no, right? But you're like naturalists, like, did I do this wrong? No, you didn't do this wrong. This answer right here doesn't work in this equation. So I usually go up to it and put a circle with an X next to it. I don't just put an X because sometimes you get lost when you're solving for X, you know. Say this guy gets kicked out. It's just like when we did the Pythagorean theorem and 5 worked and negative 5 didn't work. We had to kick that guy out of the situation. So our solutions is just 3. You with me on that? I'm going to make a simple mistake for you. It happens to the best of us. Sometimes it happens to me. Sometimes people have this for an answer instead. Our solution was 6. Where the heck did I get a 6 from? Because 6 is wrong. But where did I get it from? Right here is where I got it from. Right? You get down to the 6 equals 6 kind of thing, and you think your answer is 6. The answer is 3. Are you with me on that? So let's try again. Another one. All right. Talking myself through it. First of all, are there bars? Because if you do this on a normal equation, like the last 2 problems on your homework quiz, you're going to make a mess of things, right? That didn't even have bars with it. These have bars, right? Are the bars by themselves? What do you think? Are the bars on one side of the equal sign all by themselves? Nope. So let's get them by themselves. Please do it. We'll get rid of the plus 16 by subtracting 16. And this is where having me to guide you will save you hours of time this chapter. I have gotten the bars by themselves, and there is no letters over here, just numbers. It is time for the common sense check. This is an absolute value of something. Will that ever, ever, ever turn out to be negative 14? What do you think? That cannot happen. So we could do the algebra to solve for both of these. You would get answers. You'd have to sub them back in, and this one wouldn't check, and that one wouldn't check, and the answer is no solutions. Here's how we'll write it. That's a set bracket. We'll leave the set brackets completely empty. That is one way to write it. But because they want it in set notation, we should do it like this. Another thing that is accepted is this. That is accepted. I'd rather you use the empty set brackets. If you do this, this doesn't work. That's like the same thing twice. You know, you're saying the set of the empty set. It's like that doesn't work, right? You shouldn't do that. If you've had a teacher show you that, that's not wrong, or that's not right. It's either this, you leave it empty, or you do this, or you could literally write no solutions in English if you wanted to. Okay? So that's what we did. All right, let's keep rolling. This is probably the last one that I'm going to do with you, and then we're going to kind of turn you loose, right? There's only 8 problems. It looked like it was going to be a short day, but it was a long day because of all the checking that's involved. So, hey, when I stop asking you these questions, this is where you start freaking out. When I turn you loose, here's what your conscience needs to say. Are there bars? Answer? Yes. Are the bars by themselves? Yes. Now let's pull a switch. Right? I don't like the bars on the left. If you like it, great. I don't. Let's pull a switch. So 8 plus 5a in the bars still equals 14 minus a. Common sense check. Can't do it. Why can't I do it? There's a letter outside the bars. Right? I got a letter. So I got to do all the work. Please set up 2 equations. Check them with your neighbor. If you're at home, please don't go over to your neighbor's house because they're probably not doing this work. Well, here's what I got. The first equation is usually kind of a freebie for people. They get it. They're like, okay, I'll take what's in here and set it equal to everything exactly that I see. Over here, Don't change any signs. This is what's in the bars. It never changes. But what should it be equal to? If this is a 14, what do you want right now? Negative 14. And if that's a minus a, you want a plus a. You're cool with those two equations. Solve them both, please. Go ahead and pause the video and get that done. Solve them both. Well, let's see how we did. Left side, on the green, are we cool with a possible a value of 1? Did I do my algebra right? And the right side, I haven't finished yet. But I got down to the point of 4a equals negative 22. You might have 22 equals negative 4a, depending on which way you went around, right? But when you divide, we all know that's not coming out nice. What do you think I want, a decimal or a fraction? Told you last time I want a fraction. You know, back in the day, I really did want a fraction. I've changed my mind. If this decimal, on these absolute value guys, where we got to go through and do all the check, if it's going to come out nice, right, like this is going to be a nice clean decimal, I'll allow it. So if you want to put negative 11 halves, I'm cool with it. I will also accept negative 5.5. Is that what it turned out to be? I'm good with that, right? You know, I'm good with negative 5.5. If it was a wacko decimal, you know, or a repeating decimal, you got to leave it as a fraction, right? So if it was like negative 5.3 repeating, you'd have to keep it as 16 thirds or whatever that turns out to be. So let's sub back in. Where should we sub back in? Original problem, which is still him, right? We didn't modify him at all. We just switched him around, right? So we'll sub back into the OG, and if a is 1, you get a 8 plus 5 into bars equals 14 minus 1, which is 13, right? So I kind of cleaned a couple things up there. Absolute value of 13 is equal to 13, and that's a check, right? 13 equals 13. Let's check the other guy. 8 plus, I'm going to my calculator, and it says 5 times negative 5.5. So I'm going to do that. 5 times negative 5.5. I got negative 27.5 as a decimal. Is that what y'all got? Please do the work. Don't copy me. You know, you can punch stuff in. It'd be cool if, you know, like I could take your state assessment for you, if I could take your ACT for you, you know, but you got to do the work, right? So negative 27.5. You'd have one very brilliant math school if I did all the tests. I'd be one tired dude, though. That's a lot of tests to take. So on the other side, it's 14 minus a minus 5.5. So isn't that a plus 5.5? That minus a minus. Remember them old sign errors. That's our number one error all year long. And what helped me, I didn't punch it in. What is 8 minus 27.5? Negative what? 19.5? But it's in the bars still. And what do those bars do to that negative 19.5? Positive. So they both worked. And that's the thing, my friends. Sometimes they both work, sometimes one works, sometimes none of them work. So we'll put our solution in a solution set. Would you agree? It's very boring. It's very impractical. When would I ever need this? ACT, state math assessment, those goofy tests that could earn you a lot of free money. Why don't you and a neighbor talk yourself through number 6? So please pause the video and get that done. If you actually talk to yourself through this the way I've kind of asked you to, I know it's new and it's our first kind of tough day. You should be done by now. What is the answer to number 6? There's no solutions on this because the bars are by themselves, right? You do a common sense check and boom. And that's where the not paying attention too much to what you're doing is going to cost you a bunch of time. You can go through and do all the algebra you want. There's a fraction in there that you probably don't like either, right? You can go do all the algebra you want, check. This one's not going to check. That one's not going to check. So common sense check. Squeeze that in. 7. Let's talk. Are the bars, there are bars, right? Are the bars by themselves? Nope. So we got this 5F right here. We've got to move him to the other side. So don't we subtract? Look at this. There is a negative in front of it. It hasn't disappeared yet. So we'll do this. And this is where if you get cocky and you start working ahead, you're going to do a lot of bad things. Here's another rule with absolute value bars. You cannot distribute through absolute value bars. Sometimes it works, sometimes it doesn't work. Most of the time it doesn't work, but people are like, hey, can I just take this negative and distribute it through there? You can't do that, right? You cannot distribute through absolute value bars. Only parentheses can you do that. This right here is a times -1 in front of the bars. A times -1. How do you get rid of times -1? Divide both sides by -1. So I'm just going to show the baby steps. You don't have to do this, but if you divide this by -1 and you divide this by -1, don't those cancel each other out, right? So what comes down is the bars, so you can work with me now, equals -20 plus 5f. So you cannot distribute through the bars. Even if that was a number, right? You can't use the distributive property. We're going to divide both sides by a negative. 20 divided by a -1 is -20. -5f divided by a negative is a positive. Cool? Continue with your neighbor. Bars are by themselves. Can't do common sense because there's a letter, so set up two equations, solve them both, check them both. Please pause the video, and we'll come back. All right, so I want to set up my two equations. This is what you should have done. Here's what's in the bars equal to what I see is what I get. What's in the bars opposites are these. Then I solve them both, right? So hopefully you got 12 over here for f as a possible and 2 for the other possible. Then to sub back in, here you go. You have to go into this guy. If you go into these, you might get lucky. We just have to realize it might give you the wrong answers also. This is the only one that's going to give you the right answers. So subbing back in, I kind of just did it over here. I put 12 in for this and got a 60, and then subbed all in and cleaned everybody up, not moving stuff from one side to the other. Can't do that. If you don't have 20 equals 20, I got to take off a point because it's only going to come out to be 20 equals 20. If you did some moving of stuff over, it's like, well, I got 40 equals 40, you know. It's like, sorry, you did this incorrectly. You moved stuff over, right? It's got to be 20 equals 20. So that's true, so this guy checks. Same thing with putting 2 in. If I put a 2 in, this 5f becomes a 10, subbing all that stuff in. I got 0 equals 20 in that case, so that's not going to work. Having 10 equals whatever isn't going to work in this case because you've moved this over and you're not allowed to do that kind of stuff. So that's crazy stuff. Hey, there's just one more. Are there bars? Yes. Are the bars by themselves? No. We've got this 1/2 in front of it. Would you believe they are multiplying right here, right? So, question, can I do this? Distribute the 1/2 through there. Can't do that. As much as you'd want to, can't do it. How do you get rid of multiplication? Divide. Ew, you're right. Dividing by a fraction sucks, right? It's easier to just look at this. Would you believe this really says divide by 2 right here? This is like 1 divided by 2. I'd like to get rid of the divide by 2 part. How do you get rid of divide by 2? Multiply by 2. So showing baby steps, which you don't have to do, if I multiplied everything times 2, those cancel out and you're left with 6 minus 2x in the bars. And you got to say 3x times 2 is 6x and 1 times 2 is 2. Wasn't that so much nicer than dividing by 1/2? It's not that you couldn't do that. It's still going to give you the same thing, but everyone thinks that's the fraction. I always call it divide. You know, that's a divide by. How do I get rid of division? With multiplication in that case. So, all right, I have gotten the bars by themselves. Please pause the video and solve for x. Here were my two equations. Solving for x. You could have 0.5 or 1/2. I don't care what you have. And then the other one, I solved for x and got a -2. Subbing back in, you must go into this guy. If you go into the red one, it's not going to be good for you. So I sub in, and by putting 0.5 or 1/2 in for x, this becomes a 1. This becomes a 1.5. Don't move stuff from one side to the other anymore. Clean up the left side, clean up the right side, and it worked. I got 2.5 equals 2.5. Similarly, by putting -2 in for x, it did not work for me in this case. So, hey, if you have any questions, please come see your math teacher. It might not be me, it could be somebody else, but go see your math teacher, and please have a good one.